Hello, my name is Sharvin Anurag Kumar. My metric number is CD240031. Today I'm going to talk about the principle of movement in addition theory. The principle of movement explains how forces causes rotation around a pivot point. It states that for an object to stay balanced, the sum of clockwise movement must equal the sum of counterclockwise movement. A movement or torque is the product of force and perpendicular distance from the pivot. This principle is a vital in various fields. In engineering, it shows stability in structures like bridges and crane. In tools like wrenches and pliers, it helps amplify forces. In biology, the human body uses the principle as a muscle and bones from the level system, with joints acting a pivot to enable movement. Rotational equilibrium occurs the net torque is a zero, keeping a system balance or rotating stability. This concept is a key designing machinery and tool balance for efficiency. However, practical the challenges like a measurement error, friction, or uneven weight can affect precision. Despite the issue, the principle remains essential for understanding and designing reliable rotational system, highlighting its importance in physics, engineering, and biology.
Hello, my name is Shashmi and my matrix number is 240275. Today I would like to present about observation that we obtained from this lab work. Firstly, in test 1, the force gap for the left pivot bar was equal to the distance from the center pivot to the left pivot. Since the force F1 and F2 were the same, equilibrium was achieved when the total moment equal to 0, and this confirmed the balance of forces in the system. In test 2, more weight was needed to balance the right pivot compared to the left, but it was still less than F2. This allowed F1 to remain unchanged, and the right pivot was positioned closer to the center than the left. Reducing the force to the distance ratios, the total moment equals 0, and confirming the hypothesis and demonstrating the principle of moments, which states the clockwise and anti-clockwise moments are equal. In test 3, a 5.1 Newton concentrated load along with a distributed load was applied at the center of the beam. The reaction at support RA and RB was equal and higher than the values observed in test 1 and test 2. Finally, in test 4, a 5.1 Newton load was positioned 250 mm from RB, while 2.1 Newton loads were placed 50 mm and 150 mm from RA. The spring balance reading exceeded the value at RB, indicating that the beam was not in equilibrium. This concludes the test demonstrating how forces and moments interact under different conditions and confirming the principles of balance and equilibrium. Thank you.
So now we'll be looking at the calculation parts for principle of moment. So the first step is to identify the moment for the left pivot bar, which is noted as M1. So the formula that we can use here is F1 times D1. So it is fixed for figure A, B, C, and D. So it is 2 newtons times 0.16 meters. So we will get 0.32 newton meters. And then for the second step is to identify moment for the right pivot bar M2. It is the formula used is F2 times A. So an example is taken from figure 4.3a. So it is given that the force is 2 newtons and is times by a distance of 0.16 meters, which also equals to 0.32 meters, newton meters. For the third step is the total moment. So M1 minus M2. So example from a figure 4.3a, which is 0.32 minus 0.32 newton meters, which equals to 0 newton meters. So the fourth step would be to find the ratio of forces using the formula of F1 over F2. So the example from 4.3a, it is 2 newtons over 2 newtons, which equals to 1. For step 5 would be the ratio of distance using the formula of A over D1. The same example from 4.3a, it is 0.16 meters over 0.16 meters, which also equals to 1. So we can apply these steps, the same steps, for figure 4.3b, c, and d. So for the results we obtain for the right pivot bar would be from figure 4.3a is the force is 2 newtons, the length of A is 0.16 meters, and the moment would be 0.32 newton meters. And m1 minus m2, which is the total moment, equals to 0. The ratio f1 over f2 will be 1, and the ratio for A over d1 will be 1. For figure 4.3b, the force is 3.3 newtons, the distance of A is 0.09 meters, and the moment is 0.3 newton meters. The total moment is 0.02 newton meters. The ratio of F1 over F2 is 0.61. The ratio of distance is 0.56. For 4.3c, the force is 3.1 newton. The length of A is 0.1 meters, and the moment is 0.31 newton meters. So the total moment will be 0.01 newton meters, and the ratio of forces is 0.65. The ratio of distances would be 0.63. And lastly, we have figure 4.3d. The force is 6 newtons. The length of A is 0.075 meters, and the moment is 0.45 newton meters. So the total moment here will be negative 0.13 newton meters. The ratio of forces will be 0.03, and the ratio of distances would be 0.47. So we have plotted the graph of ratio of forces versus ratio of distances. So we're supposed to get a linear graph, but due to some inaccuracies in our data caused by external factors, such could be parallax errors or other errors like friction at the pivot point, could affect our result, but it should be a linear graph.
Hello, my name is Ismail Baramli. My check number is CD2400026. I'm gonna talk about a group discussion on how the graph obtained. The graph obtained from the result shows a relationship between the applied forces and the distances from the pivot bar. When the moment of equal magnitude by opposite directions are achieved, the equilibrium state is maintained. When the force ratios and distance ratios are taken into account, the plotted graph should really show a linear connection. And discussion or group discussion about opinion about the estimation of moment is the experimental result shows the amount of clockwise and anti-clockwise moments which are added together was almost the same based on the testing data. This alignment confirms that the theoretical expectations and supports the principle of moment. The small variations during the experiment was almost Probably caused by factors such as frictions at the pivot bar, inaccurate distance reading caused by parallax error of Next, we're going to discuss the factor that may influence the experiment if the moment is not zero. If the moment is not zero, a variety of factors could influence the experiment and result in variations. Inaccurate measurement used to compute forces or distance are one of the primary causes of errors. Resistance brought on by friction at the pivot point may throw off the balance of moment. Forcer- Forces are misaligned when they are not applied perpendicular to lever arm, changing the effective moment arm and producing inequalities. An uneven weight distribution or flows in the pivot bar could lead to more unaccounted for situation. Additionally, external force factor like vibration or inadvertent motion could upset the arrangement. The natural deformation of the lever arm under stress may change the effective distances, and even the equilibrium should be achieved. Ongoing setup mistake might have an ongoing effect which could potentially affect the results and provide non-zero moments.
Assalamualaikum warahmatullahi wabarakatuh. My name is Syahri. My metric number is CD240056. So my part is question. First, what is the principle of moment and how moment achieved? The principle of moment states that the problem of a force about a point is equal to the sum of the moments of the force component about the point. Principle of moment is an object is balanced, then the sum of the clockwise moments about a pivot is equal to the sum of the anticlockwise moments about the same pivot. The moment can achieve when the distance from the line of action of the force to the pivot was to obtain, and it is perpendicular to the force. The moment depends on the size of the force, the direction of the force, and the distance from the force to the hinge. Next question. What does the principle of moment state about the turning moments of forces acting on a body? It will produce a tendency for the body to rotate about a point that is not on the line of action of the force. It is called simply the moment. The larger the force or the longer the moment arm, the greater the moment or turning effect. If the force applied at an angle 90 degree, then it will be more difficult for turning occur. Its moment arm will be zero since the line of action of force will intersect to the z-axis. As the result, the moment of force about z-axis is also zero, and the turning moment of forces cannot occur. Conclusion. In conclusion, moment of a force depends on both the force and the location of the point about which the moment evaluates. Moment of force is equal to the sum of the moment of the components of the force after we carry out the experiment. So the principle of moment was achieved. The principle of moment for parallel and non-parallel forces was verified. During the experiment, the pivot bar is unbalanced, so we should ensure the pivot bar is in balance before we add the load. The ratio of force and the ratio of distance must be equal after calculating them, because the moment of clockwise equal to the moment of anti-clockwise. So the graph could be plotted. Lastly, when carrying the experiment, we should avoid the parallax error while measure the distance using a ruler. Overall, the experiment was successfully be done, and a slight of error could still happen.